Hey everybody, Mr. Cubby here, and in this video we're going to talk about how to find the sine, cosine, and tangent based on the coordinates of the terminal side. Okay, so these problems are going to be a little bit different. Instead of giving you the angle, we're going to give you the coordinates. We're just going to give you the coordinates and ask you the sine, the cosine, and the tangent. There's a little bit of a tricky part to this that we will chat about, but it shouldn't be too bad in general. So first, I'd like you to just take a second, this is on page 6 in your notes, to try and do example 1, 2, and 3. You might be able to do these, you might struggle. Take a minute or two to give them a try, and then we'll go over them together, and we'll kind of notice something here. Okay, so example 1, 2, and 3, try and give them a try on your own. See what you think you should do. Okay, and then we'll go over. Go ahead and pause and give that a try. Okay, so for this first one, I hope you thought, oh, well, I'm going to plot that point, 1/2 root 3 over 2, and it's asking me find the theta whose terminal side is at that point. It's asking me to find this angle. Oh, I recognize this coordinate. It's one of those 3 coordinates you have memorized. What's that angle? That angle is pi thirds. 60 degrees. Let's do it in radians. Pi thirds radians. That's not too bad. Hey, you give me the coordinate, I can work back to figure out the angle. Second question is actually even easier. They're asking us to find sine of the angle, and they're giving us the terminal side. So you probably draw it out, and you'd think about it, you'd look at this, and you'd go, oh, that's one of the coordinates I know, it's just flipped over there. Maybe you figured out that the angle is 2 pi thirds, and you thought the sine of it was the y coordinate, so you said root 3 over 2, which is correct. But you didn't even have to do any of this. If they give you the coordinates of the terminal side, and they ask you for the sine, sine's the y coordinate. That's it. Now, when you get to example 3, you can make this one as easy. So you can't just look at this and say, oh, well, they want the sine. Here are the coordinates of the terminal side. So the sine of the angle is 4. That is not correct. And the reason that's not correct is something really important. So if you think about when we started saying cosine was x and sine was y, we did that because we were looking at coordinates that were on the unit circle. What did we mean by on the unit circle? We meant they were 1 unit away from the origin. Okay, all of the points that we memorized, the 3 special ones, and them all flipped around, all of those were 1 unit away from the origin. All of these little right triangles had a hypotenuse of 1. So remember, that's why we said, because we should have said that the sine is y over the hypotenuse. That's what we should have said. But we said, oh, well, if sine is y over the hypotenuse and the hypotenuse is 1, we'll just say it's y over 1, which is y. And cosine's adjacent over hypotenuse, it's x over 1, which is just x. So the reason that we were simplified it was because the point was 1 unit away from the origin. We were on the unit circle. Is -3, 4 1 unit away from the origin? No way. So how is this example different? We are no longer on the unit circle. Okay. And so that simplification of cosine being x, sine being y coordinate, that doesn't work anymore. But we just need to make a slight adjustment. So if you look at this picture, I hope it makes a lot of sense. It's like, oh, now that hypotenuse, that radius isn't 1, it's going to be something else. So when you think about the sine of this angle, it's not y over 1. The sine of that angle, when it's not on the unit circle, is y over whatever that r is, whatever that radius is. The cosine is no longer x. It's x over r. And the tangent is still y over x, okay, because it doesn't have anything to do with the hypotenuse. Okay? So these are kind of the more general definitions of how you find sine, cosine, tangent based on a coordinate. Particularly, you need to use these definitions when that coordinate is not on the unit circle, when that coordinate that you're given for the terminal side is not 1 unit away from the origin. Yeah. I hope these make sense, though. They're actually the same thing we were doing up here, it's just our r is no longer 1. Okay? So when you look at this picture here, we're going to draw this little right triangle here, And the reason we're drawing that right triangle is because our angle is clearly bigger than 90 degrees. We can't fit it in a right triangle. So instead, we're going to look at the reference angle, and we're going to make a right triangle with the reference angle, and we're going to call that our reference triangle. And we're trying to do the sine, which is the opposite over the hypotenuse. It's the y over the r. You can label the sides. I like to label the sides like it's over 3, up 4. I'm going to label that as -3. I know you can't have a -3 length side, but we're thinking about it like coordinates, so I'm going to label it like that. So we have -3, 4, but I don't know what the hypotenuse is. I don't know what that r is for whatever circle this is on. It's definitely not 1. How am I going to figure it out? Good old-fashioned Pythagorean theorem. An oldie but a goodie. You might just recognize it's a Pythagorean triple. You do your Pythagorean theorem, and you get that r, the hypotenuse of that little triangle, is 5. So this, So the sine of my theta is y over r. It's opposite over hypotenuse. It's 4 over 5. That's it. Again, I want to emphasize that although we are finding the sine of this large angle, we are doing it by looking at a right triangle made with the reference angle, a reference triangle, right? Because that big angle wouldn't fit in a right triangle. So when do you have to do this Pythagorean theorem to figure out that when the hypotenuse isn't 1? Sure, you could do it all the time if you wanted, but it's kind of silly because you're just going to get a hypotenuse of 1. Okay. Cool. All right. Let's do another one together, and then I want you guys to do a few. Okay. So A, it's saying, hey, find the cosine of the angle if the terminal side is at -1,4. Okay. Immediately, you should look at -1,4 and go, oh, well, that's not on the unit circle. That's way far away from the origin. Okay. So what I like to do is draw this reference triangle. Again, this is the theta we're talking about, this yellow angle, but I'm going to look at the pink angle, and I'm going to look at the pink, or that green triangle. This is the reference triangle. This side's -1, this side's 4. I'm going to do Pythagorean theorem to figure out the radius, the hypotenuse. Oops, sorry. -1 squared plus 4 squared equals c squared. I'm going to solve it out by hand, no calculator. Get square root of 17. Cosine is x over r. X over r. I should rationalize the denominator just to kind of clean it up. And I get negative square root of 17 over 17. That's the cosine of. I want you guys to pause and try 2, 3, and 4 really quick. Cool. I hope this isn't too bad. Okay. So if you take a look at number 2 here, I plotted the point of the terminal side. Again, we're talking about this as our angle, but I'm not looking at a triangle with theta. I'm looking at a triangle with the reference angle. And I did Pythagorean theorem to figure out that the hypotenuse was square root of 65. By the way, the hypotenuse, the radius, is always going to be positive. And it's never going to be negative. And then I was looking for the sine, so I did y over r. Opposite over hypotenuse, y over r. And I rationalized it, and I got that. Okay. Again, our ideas about where the different trig functions are positive or negative still apply. Okay, all students take tangent is positive in the third quadrant, sine and cosine should be negative, so the sine is negative because we're in the third quadrant. So that idea still applies. Number 3, I hope this kind of threw you for a little loop. Like you went over here, you drew your picture, you did your Pythagorean theorem to get the hypotenuse. But then you realize they're just asking you for the tangent of the angle. Tangent's just y over x. So although I did the Pythagorean theorem to find the hypotenuse, I didn't actually even need it because it was tangent. So didn't need to do it. Could have just looked at it and done y over x. Done. 1. Same with number 4. You could start drawing it out here and putting down your point and stuff. You don't need to do any of this. Okay? Tangent's y over x, regardless of whether you're on the unit circle or not. It doesn't have anything to do with the radius. Okay? So it's an easy one. All right, I hope that's not too bad. Last thing I want to do, this is kind of a challenge problem. It's kind of foreshadowing something else we're going to do. Spend a minute trying to think about this question. It's a little tricky. Pause and give it a try. Okay. So why this question is different is they're asking you to find the angle and they're giving you the coordinates of the terminal side. So you draw it out, you got this point, you label your sides, you can do your Pythagorean theorem to get your hypotenuse. And you're like, well, I can tell you what the sine of the angle is, I can tell you what the cosine was, I can tell you what the tangent was. But how do you actually figure out what this angle is? Well, I can like guesstimate it's like it's more than 90, it's less than 180. Oh, it's like maybe like 115 degrees, but how would I actually like figure out what it is? Again, this point is not a famous coordinate. This isn't like, it's not like it's 120 degrees or I would know it. So how do you actually figure out exactly what that angle is? You have to use your calculator. I know, I hate my calculator too. I hate it, but sometimes we got to use our calculator. Okay, so Mrs. Lemke is going to go over in a video how you actually do this and like how do you ask your calculator what this angle is. But we're not going to talk about it now, but I just want to kind of foreshadow that. So although we can figure out the sine, cosine, tangent pretty easily doing this stuff, we actually can't figure out what the angle itself is without our calculator. All right, that concludes this video. Thanks for watching, guys.